So we've got this connected graph here, and we want to apply Dijkstra's algorithm on it. Now, normally, Dijkstra's algorithm, right, you want to apply to really complex systems that you can't really easily work out with just by looking at it like this. You might be able to find the shortest distance from A to F just by kind of looking and doing a little bit of addition in your head. But if you have something with like hundreds of nodes with multiple varying quantities in between, it's going to be really, really hard for you to work through that in your head. So the reason that we do this with these kind of simpler examples and doing it by hand rather than writing a program to do it is just to kind of understand what's going on at a more fundamental level. So this I'm going to work through in Excel, and I want to kind of keep track of my progress by using a table here. So the first thing I want to do is I want to start up my initial node, which is A. So I'm going to label this guy A. So this is my analysis there. And what I need to do is find all the distances from A. If it's not connected, then the distance initially is going to be infinity. So A is connected to itself. I'm going to put 0. Oh yeah, and so here's my rule. Whenever I put a letter up here, I also highlight it. Or maybe I can underline it, whatever you want to do, just to let myself know to never check this again. I've already checked it. Once you've checked it, Dijkstra's algorithm should mean that that's already at its lowest point. So, what I need to do is look at the other connections. So in this case, B has a connection of 3. And I'm going to do a different notation here. I want to say how I got to B, in which case I got to B through A. And this is just information that you can actually use later to kind of figure out what path to actually take from the distances that you've calculated. Now, B is not connected to C, so I'm going to put infinity there. Or sorry, A is not connected. It is connected to D, their distance of 5. Not connected to E, and not connected to F. Now, we need to look at the smallest distance that isn't already highlighted, that we haven't checked already. So in this case, we've already checked A, which has a distance of 0, but we're not going to check it again. So that means that we're going to look at B, right? B's got the smallest value. So if we put B here, and what we want to do is, first we want to highlight it, and just a second, my cat is trying to eat my headphone cable. There we go. Alright, sorry about that. So we've got B here, and we want to look at all the distances from B. So B to C is a distance of 4, and we add that to the current distance at B, which is 3, right? We've had to go 3, and then to go to B or C is adding 4 more, so that's 7, which is lower than infinity. So we got to C through B with a distance of 7. B is also connected to D, and we add that 3 on there. 3 to this connection here of 2 is 5. It turns out that it's the same as this connection that we've already got there. So we can either choose to maybe replace it or keep it the same. I usually always opt to just keep it the same. And it looks like B is not connected to E or F. So I'm going to keep that at infinity and infinity. And as it turns out, your distances aren't going to change for any of the nodes you've already checked. So we can just kind of copy and paste those over. Now, our next smallest value appears to be D, right? Got D there. So I'm going to put D there, and I'm going to highlight it. So we can copy this guy, and we can also copy this guy. Now, let's look at D's connection to C. So that's a length of 1. So we've got 5 plus 1 is 6. And 6 is lower than the current value at C. So that means I want to do D6, right? We got to C through D, so we do D6. D is also connected to E and F. So if we add those up, we actually get D10 and D11. Alright, now let's look at our next lowest value, which happens to be C. So we're going to make a C column, highlight that there, and now let's look at our distances from C. Well, first we can copy all these guys. So that means we need to look at C to E, which happens to be connected with a distance of 1. So we add 6 plus 1, which is 7. So we got, which is lower than 10. So that means we change this to C7. And then what we want to do is we want to look at, what are we doing right now? We're doing C, right? We're doing C to F, and it's not connected. So that means we just want to keep that at what it is, which is D11. All right, and now our next lowest one is E. So we want to look at E, highlight that, and we can just, lo and behold, we can just connect this again. And so E's connection to F has a distance of 2. And so E already has a 7. So that's 7 plus 2, which is 9, which is less than 11. So that means we can actually get there this way. E 9. And there we go. That would mean that our next thing that we want to look at is F. The moment we highlight F, or our final node, we know that we're done with the algorithm. So I guess I can just copy this over there kind of for completeness. And then this right here, this is kind of our end data that we can use, you know, for whatever we really want. In our case, we want to get from F to A. So if we start at F, we know that the next hop is E. So then we go to E, and then how do we get to E? Well, we went through C. So then we go to C. How do we get to C? We went through D. How do we get to D? Well, we're directly connected to A. When we get to A, we know that we're there. So I guess it should be noted that there are a couple right solutions here actually. We have to go F to E and E to D, but remember we had that choice where we could go A, B, D, or directly A to D. They're the same length, and I just opted to keep this one rather than this one. So there are potentially a couple right solutions, but this also tells us other things, right? Like I could say, how do I get to something like, how do I get from A to C? Well, it's a fragment of the path that we already had, but you can see that C, if I'm at C, I need to go to D, and if I'm at D, I can go directly to A. So this kind of tells you a little bit of information on how to make other paths as well. But this is just kind of a nice, handy way to document your progress as you're working through the algorithm. Obviously, this stuff isn't the final end answer. This is just the progress to get to this last column, which is our final answer that can tell us kind of everything we need to know about this plot or this graph.